Hello and welcome to another tutorial of the thermal system design class. So today we're gonna explore some of the other matching methods that there exist. So from last tutorial, this is the method that we have. So let's say for example that we want a different method on our geometry. So if we go to right click, insert method, it's gonna give us this option. And it's gonna ask us to select a geometry. So we're gonna select this geometry, we apply it, and it's gonna give us the selected geometry. So we can see here in the definition that the method is set up already to be quadrilateral dominant. Let's say for example that we take this and we generate it. So this is gonna be the method that we're actually gonna get. I'm gonna reduce the number of elements just to make our optimization a little bit faster. So this is what we would get if we select quadrilateral dominant. But let's say for example that we change it to triangles, we generate it again. We'll get this type of distribution on the mesh. We can also select multi-zone. This will be our matching. So in different scenarios, we're gonna have different meshings. So it's something to consider depending on the problem that you have. So let's clear this data and let's start from the beginning. Let's delete this method. And let's explore another option that we have here. We go to insert and we can go to sizing. So on sizing, it gives us different options. For example, we can select the entire body. We can see here on this toolbox that it gives us the different options for the selection. So we can select the entire body. We apply it, gives us the body. But we can also select just the face. It's gonna give us just your face. So this will be very helpful whenever you have a 3D simulation and you want a finer meshing on maybe just one of the faces of your system. For example, if that face is interacting directly with your domain and is the one part of interest for you, so it would be very good, and it would be advised for you to select that face and have a finer mesh in order to have more accurate results. But in this case, let's say for example that instead of having a face, we select some edges. And we select the top one and the bottom one. It's gonna give us this. It's gonna ask us for the number of elements or the number of divisions. So this is gonna be just one division. It's just gonna give you a very coarse meshing. But let's change this division to 100. So we can see in the preview it gives us more elements. And let's generate this mesh. And this is what we would get if we use the sizing tool. So we can see here that on advanced we have different options as well. So soft, let's say for example that you have already that you mesh the face of this rectangle first. So soft is allowing you for your meshing to be more lenient to overlapping with other type of meshings. So if you have it on hard, it's gonna run optimizations a little bit slower. So for now, soft is gonna be our option. There's another important tool here. It's called bias. So it's basically asking you how you want to divide your meshing. And we'll do that in a minute. It's updated. Let's say, for example, that you want a different meshing from the top and the bottom than from your left and right edges. We can add another sizing on top of that one. You can select the geometry. We make sure that edge is selected. And then again, select our edges. But let's say, for example, number of divisions. So let's say, for example, that instead of 100, we want just 50 divisions. Let's generate this. And we can see that it's gonna give us somewhat of a very similar to a hybrid meshing, because we have here on the edges on the right side and the left side we have some unstructured mesh, and we have a structured mesh on the middle. We can always fix this, and we can redefine our mesh with another important tool called mapping. So if we go to insert and we go to face matching, we select this face and we update it. It's gonna give us a structure mesh instead, as we can see. But let's say, for example, now we want more divisions. And let's say also that on these edges we want some bias. Let's say that we want that maybe right here bias factor, let's say 100. So let's say, for example, that we want a finer mesh on this corner because for some reason we have more interaction with our domain on this corner. So we can change the bias and we can say that on this edge, the meshing is going to be coarser on the top rather than on the bottom. So if we do that and we update the mesh, we can see how the meshing changed and it's finer here on this corner. So those are some of the different features of the meshing. There's definitely more to explore, so we will be exploring more in the future tutorials.